Okay, the formal lecture today won't be that long. I should be able to knock it off pretty quickly, and then you'll have more time to work on the word problem, the max min problem there. Okay, and thank you again, Jonathan, for sharing. Anybody needs it there? Okay, so here's where we are. We're going to 11.1 today. Okay. The basic topic is the derivative of the natural log function. How do you take the derivative of natural log of x? And Tuesday, the new derivative is e to the x. Now, I won't do any homework problems from 11.2, but I'll give you the derivative. I thought it would be at least better if I showed you what the derivative is. You can put it on your cheat sheet, obviously, but if I wait until Tuesday, that means you only have 2 days to learn it. This way, at least, I've given it to you. You have a whole week before the exam to prepare for the derivative of e to the x. So I'll lecture on 11.1. We're doing the derivative of natural log of x. Next time we're doing the derivative of e to the x. Okay, and then the test is a week from today, Thursday the 19th. That's our 4th exam. Okay, so you should know the way it works by now. So you will turn in all of this stuff. Is that right? So this gets turned in. And then after that, we have one last test and then the final exam, and then that's it. Okay, so we're getting near the end. We only have about a month left. So we do the usual one section a day. So next Thursday, exam 4. Then Tuesday, the 24th, 12.1. We have a holiday for Thanksgiving Day. Then 12.2, 12.3, 13.2. Last regular exam is on December the 10th. Okay. I say return exam 5. You know, I made this before I knew we were, you know, not meeting face to face. Ordinarily, if we met face to face, I would give it back to you on this tape. Now, you know, I just email you the exams over the weekend or something like that. But yeah, our final exam is scheduled to be on the 17th, and then we're done. Okay. So for the final exam, it'll be questions similar to previous exams. So if you say, how do I study for the final exam? You can just study off the previous exams. Okay. And for cheat sheets, you can just keep all the previous cheat sheets. I hope you didn't throw them away. But if you already threw them away, then you have to reconstruct it. But I think the easiest thing to do is take the formula sheet you have for the first test, second test, third test, fourth test, fifth test, and just bring them all. No reason to redo it. Don't reinvent the wheel, so to speak. So if you still have them, then just use them again. If you already threw it away, make it again. I guess it's a nice review, I guess, if you have to remake it for the final exam. Okay. Well, something else I was supposed to let you know, I'm one of the instructors being evaluated this semester. I sent you via Canvas announcement something not too long ago, within the last hour or two, something like that. It's open if you want to evaluate me. You can be as candid as you want. I don't get to see them until next semester after I've turned in your grades. So you can make any comments that you wish about me and my teaching abilities or inabilities or whatever the case may be. Things, of course, are tougher now with the COVID stuff. So, but you know, hey, that's the way it goes, right? So, I was supposed to let you know you're welcome to submit it. I mean, nothing's going to happen to you if you don't. And I think you're supposed to submit anonymously anyway. But you're welcome to evaluate me, so you can say, you know, your opinion of me as an instructor. And I think there's a limited time. It's not open for the rest of the semester. It closes in a few weeks, I think. So anyway, so that's how that works. All right, so any quick questions anybody has? Otherwise, we'll go ahead and get started. Well, at this stage, if you want to ask a question, go ahead and mute yourself, because if you put it in the chat, I can't see the chat right now. The last thing I saw was Jonathan put something in the chat. Whoops, I stopped it anyway. Oh, well, too late. Well, since I'm here, I might as well check the chat. And that was Jonathan's. Okay, so thanks again, Jonathan. All right, so I don't hear any other questions. Let's go ahead and get started with the new material. And then when I think I'm done, we'll go ahead with the quiz. Okay. So share the screen again. I accidentally stopped it. If I can get it back here. All right, so we are here, 11.1, the derivative of the natural log function. Okay, and we have 1 to 24, 43. Again, I'll do as many evens as I can. And again, I hasten to add, it's my evens, which may not match your evens, but still, you're learning material anyway. Okay, so the natural log function, ln of x, so derivative of logarithm functions, 11.1, my page 694. And here's the formula, which may not be on the same page as you, but you've definitely got it somewhere. My page 695. Okay, if y equals natural log of x, dy dx, the derivative is 1 over x. Okay, so put this on your next formula sheet, which is the test for next week. Okay, the derivative of natural log of x is 1 over x. Okay, and that also involves the chain rule. So if you have ln of something more complicated, you would go 1 over that thing times the derivative of that thing, and I'll show you how that works. Okay. So the derivative of natural log of x, 1 over x. That's the new derivative. Okay. And if you want to put it on your cheat sheet, you may. I'll go ahead and mention again, if we were meeting face to face, I would make you memorize it. But since we're not, I'm not. Okay. Now, we sometimes have to use our properties of logs to make things, quote unquote, better. So page 700. Okay, so here are some functions that we're finding derivatives of. Okay, I'm going to mention something quickly about 13 through, I guess, 18, at least my 13 through 18, for question A and question B. So before going on to it, okay, they actually should have the same derivative. So you get to pick whichever one you think is easier. Okay, let me show you what I mean. Okay, if you look at A and B for 13, my 13, you probably have something similar, or it's offset by a couple of problems, whatever. Okay. Algebraically, these are the same. Okay, this is a property of logs. ln of something divided by something is ln of the top minus ln of the bottom. Okay, but this is usually easy to take a derivative of. Here you have to use a quotient rule. Quotient rule is one of our least favorite, right? We don't want to do the quotient rule. Okay, look at 14. Okay, ln of a product, something times something, is ln of the first plus ln of the second. And this would be the easier one. So in other words, when I get to these problems, and when you get to these problems, whether they're the very same one or not, it doesn't really matter. Do the easier one. I'll be showing you the easier one in general. Okay. There's also a property of logs. Let's look at, say, 16 and 15, same thing. Okay. ln of x to the fourth minus 1 cubed. One of the properties of logs is you can bring the 3 down in front. So it looks like this. 3 ln x to the fourth minus 1. And this one is easy to take the derivative of. You don't have to fool around with the chain rule. Okay, likewise for 15. Okay, this one looks harder. ln of cube root of x squared minus 1. Okay. Well, remember, cube root, you can think of it as raising something to the 1/3 power, and that's how they got the 1/3 out in front. Okay, so again, what I'm really trying to say for all of these problems, A and B are the same. A and B, they're equivalent. So do the easier one. Okay. Like for 18, which I may end up doing if I get something equivalent. Yeah. So this one looks pretty hard, right? You'd have to go 1 over that thing, and then times the derivative of this, which is quotient root. This is much easier because it's ln of x cubed minus ln of x plus 1, and then the 3 gets to come in front. Okay, so A and B are the same for 13 through 18. Right? So that's the bottom line behind all these. Okay, so I'm going to go ahead and get started with, again, my evens. Okay, so just casually looking at some of these. Okay, so my number 2 matches, my number 4 matches, my number 6 matches. Okay, so it looks like a lot of them do match this time. But anyway, we'll see how it goes. Okay, so find the derivatives. And I'll go down to evens. Okay, so number 2, y equals 3 natural log of x. So it's a function with a number in front. Okay, number times a function. The derivative by formula is the number. Just copy the 3 times the derivative of the function. So what's the derivative of 1 over x? What's the derivative of ln x? 1 over x. And then 3 times 1 is 3. So final answer is 3 over x. Okay, so the derivative of natural log of x, 1 over x. We will do the chain rule also. If you have ln something more complicated, then we'll do the chain rule. In fact, number 4 is a good example of it. Y equals ln of 5x. Let me keep the book here so I can see it. Okay, so this is the chain rule. It's ln of something. So you first go 1 over that thing. So 1 over 5x. And then the chain rule says times the derivative of the inside function. We've done that before already. Okay, so what's the derivative of 5x? 5. And notice the 5's cancel out, so you just have 1 over x again. So the derivative of ln 5x is also 1 over x, believe it or not. Okay. Okay, number 6, ln of x cubed. I'm going to show it to you 2 ways, the hard way and the easy way. Okay, first let me do the hard way, just take it as it is. Okay, natural log of x cubed. So the derivative, first you go 1 over whatever's behind my pen. So 1 over x cubed. Then by the chain rule, it's times the derivative of x cubed, which we know is 3x squared. So I have 3x squared divided by x cubed. X squared, x cubed, you can cancel the x squared with 2 of these, but there's still going to be 1 left over in the bottom, so 3 over x. So the answer is 3 over x by the harder method. Okay, now let me show you the easier way to do it. So the problem's actually finished, but I'll dig a little deeper. Okay, starting all over, ln of x cubed, right? Much easier is to bring that 3 in front. That's one of the properties of logarithms. You might recall from a long way back. Okay, if you have ln of x to an exponent, that exponent gets to come down in front, 3 natural log of x. So now the derivative is 3 times 1 over x, or 3 over x. Okay, so you can see you get the same answer. But this way was much, much better, much faster, as I think you can see. Okay. All right, so again, the derivative of natural log of x, just natural log of x, 1 over x. We're doing variations of it, including the chain rule, as you can see. Okay, here's number 8. Y equals natural log of 6x plus 1. So it's not just ln x, it's ln of something more complicated. Okay, and in case you're wondering, there's nothing you can do with this. Like you said, can I distribute, use the distributive property? No, you can't. Like ln 6x plus ln 1 doesn't work that way. Okay. So in general, you would go 1 over whatever is behind my pen, and then times the derivative of the inside function. Okay, so 1 over 6x plus 1 times the derivative of 6x plus 1, which is just 6. And well, 1 times 6 is 6. So final answer, 6 over 6x plus 1. Okay, and watch out, you're not supposed to cancel the 6's here. Right, you don't cancel once you add or subtract something. Okay. Now, if they didn't have the plus 1, like that, 6 over 6x, no additions, no subtractions, then you can cancel the 6's. But just like this, no, you can't do anything with that. Okay, then it gets a little bit more complicated, I guess. Number 10. Y equals natural log, and ln stands for natural log or log natural. 8x cubed minus 2x minus 2x. Let me check the book. Yeah, that's it. Well, let's get this out of the way. What's the derivative of negative 2x? Negative 2. Okay, so that's finished. Right. So let's concentrate on this now. The derivative of ln of whatever, you go 1 over that thing. times the derivative of that thing. Okay, so 1 over 8x cubed minus 2x times the derivative of 8x cubed minus 2x. So the derivative of this is 3 times 8, 24x squared minus 2. And yeah, this normally happens. Just slide that on top of the 1. That times 1 is just that. So final answer, 24x squared minus 2 over 8x cubed minus 2x minus 2. And there we go. Okay, then continuing on. Number 12 looks a little bit harder. And let's see. It says find ds dq. Don't get scared by ds dq. It's still a derivative. And it tells you the variables are s and q. I'll show you what I have. Find ds dq. So don't let it freak you out. Oh, what's this ds dq stuff? It still means derivative. The variables are s and q. That's all. So natural log of q squared over 4 plus 1. I'm going to treat this as 1/4 q squared to prevent from having to do the quotient rule. Okay. So again, my suggestion, if you have a constant either on top or bottom, change it. So like this, 1/4 q squared, I think it's easier to deal with. All right, so here we go. 1 over the whole thing. Even though you got a fraction inside a fraction, that's the way it goes. So 1 over 1/4 q squared plus 1 times the derivative of 1/4 q squared plus 1. So the derivative of this, well, the derivative of 1 is 0, so forget about that. 2 times 1/4 is 1/2 q. So 1/2 q is on top. Okay, so I got 1/2 q over 1/4 q squared plus 1. Technically, that's correct, but you shouldn't leave your answer like that. That just looks too weird to have a fraction on top of another fraction. So to clear the fractions, this is sometimes called a complex fraction. You don't have to write that down, but you may have heard a complex fraction when you have a fraction inside a fraction. So get rid of that 2 and the 4 by multiplying top and bottom by 4. Makes it look nicer. So 4 times 1/2 q is 2q. 4 times this. So 4 times 1/4 is 1. So q squared plus 1 times 4 is 4. So final answer, 2q divided by q squared plus 4. Okay. Okay, then starting with these, I'm putting 14a, 16a, 18a. Remember, a and b are the same, at least in my version. I'm guessing it's the same in yours. Okay, but we said the answers are the same. A and B are algebraically equivalent for 13 all the way through 18 in my version of the book. So I'm only doing the easier one, which is part A. So even though I only put A, I'm really doing all the B's because they're the same answer. So y equals ln x minus 1 plus ln 2x plus 1. Okay. And just so you know why it's easier, okay, if I did the original 14b, you'd have to do a product rule. You'd have to go 1 over that and then times the derivative of the inside, which is a product rule. And you don't want to do that. Usually once you do the properties of logs like this, it becomes much, much nicer. Okay. So in short, the A problems are easier than the B problems. Okay, so derivative of this, 1 over x minus 1 times the derivative of x minus 1, which is just 1, plus 1 over 2x plus 1 times 2. So just slide the 2 with the 1 times 2. So final answer, 1 over x minus 1 plus 2 over 2x plus 1. Okay, and a reminder, do not try to cancel the 2's here from algebra, right? You're not allowed to do that.
Professor?
Okay, yes, question?
Sorry. Before you move to another question, can you go back to the previous exercise, please? No, the same one that you just did. Yeah.
14a? Mm-hmm.
So, yeah, and the second part of the first of the derivative there, what is the 2?
What is this 2?
Yeah.
Okay, so that's the derivative of the inside function, 2x plus 1. That's part of the chain rule. So you do the outside function's derivative times the derivative of the inside function's derivative. So the derivative of x minus 1 is just 1, right? So technically it's times 1, but if it's times 1, you don't have to write it. This one you definitely have to write because the derivative of 2x plus 1 is 2. So that's where that 2 comes from.
And you're multiplying. Well, are you
Correct.
not?
We're
Are you
multiplying
multiplying
2
it?
by this fraction, which means 2 times 1 is 2. Okay. Is that all right?
Thank you. Yeah.
Okay, you're welcome. Okay, 16. Again, A and B are the same. I'm only going to do A. Part B, I believe they have the 3 floating up here. Take a quick look at that. Yeah. So that derivative will be much harder because you'd have to do another chain rule. But this one's easier. So what's the derivative of this? You just copy down the 3. Then you differentiate the rest of it. Okay, what does differentiate mean? Take a derivative. So you go 1 over that, 1 over x to the 4th minus 1, times the derivative of x to the 4th minus 1, which is 4x cubed. And now you just multiply all of these. 3 times 1 times 4 is 12. So 12x cubed over x to the 4th minus 1. And never mind about this. I don't think this applies. That was probably the last time I taught. Somebody asked a question about that. So just forget about this, I think. Although it's true, the derivative of x cubed is 3x squared, but don't worry about that right now.
Excuse me, sir.
Okay.
So for 14B, we do that still, or
All right, 14b you don't have to do. I'm really saying you don't have to do any of the b's, just do all the a's. So for the odd ones that you're doing, I guess 13, 15, 17, just do the a part. It's
okay?
easier.
Thank you.
Yeah. Okay. Let's see, where was I? 18. Yeah, before I do 18, let me show you the b. It's much, much worse if I took it just as is, right? You go 1 over that, which is a fraction, so it's 1 over a fraction, and then times the derivative of the inside, well, you'd have to do the quotient rule, which is probably our least favorite one. Right? By the way, all the previous rules, if you've forgotten them, go ahead and put it on this cheat sheet. Like I say, I forgot what's the product rule. I forgot the quotient rule. I forgot the chain rule. Put it on this cheat sheet also. You may do that. But using properties of logs, we get this, which is way better. Okay, whoops, I was pointing at the wrong one. 18. Well, still same concept. Right. So take the derivative of this thing. So 3 ln x. We already did that. That was the first one I did, 3 ln x. 3 times 1 over x, right? So 3 times 1 over x, or 3 over x, minus 1 over x plus 1 times the derivative of x plus 1. That's just 1. So I decided not to write it this time, and that's pretty much it. I mean, anytime if you have to multiply by 1, just leave it out, right? Just forget about it. So that's my answer. So quite nice, as you can see. Okay, then the last ones of the evens, they give you some pretty messy ones, but you can make them nicer using the properties of logs. Okay, so we only have to do what? Where are we? 20, 22, 24, and a word problem 43. Okay, and then we'll almost be done. So it's a little bit longer, a few more minutes. Okay, number 20, ln t cubed times t squared minus 1. Now, if I tried to take the derivative just as is, right? Cover this up. You would have to go 1 over that times the derivative of the inside, which is a product. Okay, and I don't think I want to do that. Okay. Instead, use the properties of logs. We have ln of something times something. It's ln of the first plus ln of the second. In other words, ln of t cubed plus ln of t squared minus 1, property of logs. And then you can even make it easier. Can you guess what happens to that 3? Comes in front. 3 ln t plus ln t squared minus 1. Okay, again, in case you're wondering, no, there's nothing else you can do with ln t squared minus 1. Like you say, can I break that up or anything? No. Okay, just leave it as it is. But to take the derivative of this is much, much better than the original. Okay, so now we're ready. So S prime, no, I mean, that's the same as this. The author seems to be having just quite a bit. So it's 3 times 1 over t, 3 over t. What about this one? 1 over t squared minus 1 times the derivative of t squared minus 1, which is 2t. And then 1 times 2t is just 2t. So final answer, 3 over t plus 2t divided by t squared minus 1. And you can just stop there. Don't try to get a common denominator or combine it. No, we're not into that right now. Okay, we'll just leave it as is.
So, Professor, in the beginning of the derivative, there 3 over t. Are you multiplying it by 3? Is that what you said?
Yeah, I already know the derivative of ln t is 1 over t. So it's 1 over t times 3, which is 3 over t. Right, 1 times
Why
3.
times 3? Why times 3 though?
Right, it's 1 times 3, which is 3 divided by t. Okay.
Because 3 is the derivative?
No, 3 is a constant. Okay, or just think back to the first one I did. Number times a function. It's really the same as this one, except instead of a t, they have x. So the derivative of a number times a function is the number, 3, times the derivative of the function, 1 over x.
That was very
Can you
helpful.
show
Thank you.
Can you show 6?
Sorry?
Can you show number 6? I think that number 6 might be a little similar.
This one over here?
Yeah, where the exponent comes to the front.
Exponent comes in front, right, which is exactly the same concept as this one. Again, the only difference is instead of x, it's t. Whoops, where'd it go? Here. Right, so 3 comes in front. Yeah, this is the one you want. So 3 times 1 over x. And 3 times 1 is 3.
Thank you.
Got it. Thank you.
All right, welcome. So we can leave it like that. Okay, now 22. Right, to take it as is real bad. Okay, you'd have to go 1 over that whole thing, and then there's a 1/4, and then there's a quotient rule. Okay, it's way better using properties of exponents. Okay, so first thing I'm going to do is take the exponent down. 1/4 gets to come down in front. So that way I don't have to fool with the 1/4 anymore. ln of a quotient, something divided by something. And now, this is not calculus, this is not taking a derivative, this is algebra. ln of something divided by something. Leave the 1/4 alone. ln of the top minus ln of the bottom. And I claim taking this derivative is much, much nicer. No quotient rule. Okay. Well, there's still going to be some chain rule, but not as bad chain rule as if I took it from here. I mean, if you took it from here, you'd have to bring the 1/4 down, then 1/4 minus 1 is negative 3/4. It's a mess. Okay. This is much, much better. Okay, so again, the 1/4 comes down. ln of, let's say, A over B is ln A minus ln B. All right, so now I take the derivative of this. So dy dx means derivative. So what do I do with the 1/4? Just put it. Just write down the 1/4. And now inside brackets, I'm differentiating all of this stuff. So 1 over, 1 over, right? So 1 over whatever is behind my hand times the derivative of that. Same thing here. 1 over that times the derivative of that. Okay, so here we go. 1 over 3x plus 2 times the derivative of 3x plus 2, 3. Same thing over here. Minus 1 over that, 1 over x squared minus 5, times the derivative of x squared minus 5, 2x. And yeah, for almost all these problems, you multiply by 1, so just slide this 3 times the 1, 2x times the 1, and it just becomes part of the numerator. So final answer, 1/4, parentheses, 3 over 3x plus 2 minus 2x over x squared minus 5. And just leave it like that. Don't bother to try to combine this and get a common number. That's not what we're trying to figure out right now. We just want to leave it like that. Okay. Okay, then the last even one, 24. And then I have one word problem, which was 43, I think. But it's not really that difficult. Okay. And then I would just about be done. But I do want to introduce the next derivative, so at least you can put it on your cheat sheet and tell you where we're headed. Okay, this is ln of a product, something times something, right? So it's ln of the first plus ln of the second. Okay, ln of A times B, ln of A plus ln of B. So I put ln of x squared plus ln of x to the 4th minus x plus 1. Now, you can't do anything with this. X to the 4th minus x plus 1. Just leave it alone. Okay. So you might say, can I distribute? No, it doesn't work that way. So that's as good as it gets. This one, however, you can do something. ln of x squared, 2 comes out in front, 2 natural log of x. Okay, so now I'll take the derivative of this thing. So dy dx, which means derivative, 2 times the derivative ln x, 2 times 1 over x. So 2 times 1 over x, 2 over x. Derivative of this, 1 over all that, 1 over x to the 4th minus x plus 1, times the derivative of this whole thing. So that would be 4x cubed minus 1. And the derivative of 1 is 0, so just leave it. And again, just slide the 4x cubed minus 1 times the 1, so that becomes a numerator. So my final answer is 2 over x plus 4x cubed minus 1 over x to the 4th minus x plus 1. And just stop there. That's as good as it gets. Okay. Okay, that's it for now. Now I'm going to show you the one word problem, 43. Then I'll be done, and then I'll show you what 11.2 is about. And then I can give you the quiz after that. So let's see. Where was it? 43. Yeah, here we go. Let me just see if it matches my 43. 1,500 plus 200. Yeah, looks like it's the same. Marginal cost. So here's a cost function in dollars. Cost C of x is 1,500 plus 200 natural log of 2x plus 1. Find the marginal cost function. Aha. So marginal means derivative. Plug in 200. Interpret the results. Okay. And let's see. Total cost functions are always increased because producing more items costs more, but that must be true of the marginal cost function. Does it apply in this problem? Okay, so we'll see what this is talking about. All right, so here's a cost function. So if you're in a business, here's a cost. Let's find the marginal cost, which means derivative. So C prime. Derivative of 1500, 0. Derivative of 200, ln blah, blah, blah. So just copy the 200. And then how do you take the derivative of ln 2x plus 1? 1 over that, 1 over 2x plus 1. And then by the chain rule, times the derivative of the inside, derivative of 2x plus 1 is 2. So 200 times 1 times 2, 400. So 400 over 2x plus 1 is my answer. Okay, then part B, it says, find the marginal cost when 200 units are produced and interpret your result. So I plug in 200. So 400 divided by 400 plus 1, that's almost 1, 0.9975. In fact, if we were to round that off, it's $1. So interpretation, the cost for producing the next item, the 201st item, so you're at a level of producing 200 units. The cost of producing the next item is about $1. And then what are they saying for part C? Image here, sorry. Total cost functions always increase, but then must be true of the marginal cost function. Okay? So if the cost functions always increase, the marginal cost must be positive quantity. Does it apply in this problem? Okay. So C prime of X should be positive. The more you produce, the more the cost. Slope should be positive. So if you were to graph it, it should be positive. And let's look at the marginal cost function. 400 over 2x plus 1, that is positive if X is positive. And we're only talking about positive quantities, right? Whatever we're producing, okay, it's a positive quantity. We're not selling -5 items, right? We're selling a positive quantity. So if X is any positive, 400 is positive. 2 times a positive plus 1 is positive. Positive divided by positive is positive. It'll be positive. So C prime of X has to be greater than 0. Okay, and that pretty much does it for the lesson. Okay, it's only about 6:20 something. Okay, so what I'm going to do is at least show you this. So I'll let you ask questions also if anybody has anything. But 11.2, the new derivative, I'll show it to you. Again, if I wait until Tuesday, you only have 2 days to learn it. But if I at least show you what the derivative is, you have a week to do it, even though I'm not doing any problems with it. Okay, so 11.2, the derivative of the exponential function e to the x. Okay, and in case you're wondering, on a calculator, you don't really need a calculator to do any of these, but e to the x is normally above your ln. So if you look at your calculator, ln and e to the x are almost always paired with each other. On a regular scientific calculator, looks like it's right here, ln and e to the x. Kind of hard to see, but it says e to the x there. Okay, so what is the derivative of e to the x? Very nice. The derivative of e to the x is itself. The derivative of e to the x is e to the x. Okay, so 11.2, my page 703. Okay, so put that in your next cheat sheet. I won't do any homework problems in it, but at least now you know the cat's out of the bag. The derivative of e to the x is itself, e to the x. But that does mean something else that I have to show you. So for the derivative of e to the x, Okay, let me write it like this. It's nice. Here's a function which is its own derivative. We won't prove it. Okay, we'll just say that it works. But that means do not go like this. Watch out for this. The derivative with respect to x is not x e to the x minus 1, even though it seems plausible. Right? And I know what students are doing. They're saying, oh, bring this exponent down and subtract 1, just like the power root. Okay, so don't do this. It's actually easier. Derivative of e to the x is itself just e to the x. Okay, and it also has its own chain rule. Okay, so I'll show you one of those. That's about it. So suppose I have y equals e to the x squared. Okay, so this is a chain rule. The derivative of e to the x squared is e to the x squared, but because of the chain rule, it's times the derivative of x squared, which is 2x. 2x e to the x squared. So that's the way that it would work. Okay, so I just wanted to let you know that. That's how that's going to work. And so next time, okay, so let's do it this way again, just to have better use of our time. 11.2, it probably won't take the entire period again. I'll most likely end something like around now, 6:20, 6:25-ish. And then the rest of the time, I'll let you ask questions for review, anything here. Okay, so, and of course, you know what to submit for the homework. It's everything from here. So the more questions we can get out of the way on Tuesday, the fewer I need to take on Thursday, and then I can give you more time for the test. Is that right? Okay, so next Thursday, as usual, I'll let you ask questions, but if you kind of want to get it all out of your system, so to speak, next Tuesday. So another homework assignment for you is come prepared with any questions you might have from 10.1, 2, 3, 4, or 11.1. So after I finish lecturing on 11.2, you can get more questions out of the way on Tuesday. Then I don't have to answer as many on Thursday, so you have more time for the test. Is that right? Okay. All right, so I'm now done. Put that away. Let me stop the share temporarily. And let's see. So what formula to remember from 11.1? Okay, so that was the section we just had, right? It's a derivative of natural log of x is 1 over x. Let's see, and 11.2. Okay, I can do that again quickly. So the key formulas, share the screen again here quickly. All right, so you know the way the game works. This is what you turn in next Thursday for the test, right? So that's going to be the 19th. You must have at least 70% done, but hey, I end up doing, a lot anyway, sometimes half or even more than half. Okay, so the one formula for 11.1, it's my 695, but wherever it is, here it is. If y equals natural log of x, dy dx is 1 over x. Put that on your cheat sheet. And this is still being recorded, so if worst comes to worst, you can look at the video and catch it there. Then 11.2, which I'm not doing any today, but I want you to at least see it and put it down on your formula sheet. Okay, 11.2, my 703. Okay, if y equals e to the x, dy dx is also e to the x. So e to the x is its own derivative. Okay. All right. Any other questions? Otherwise, we'll go straight to the quiz. So let me check. Anything else there? All right. Nope. Okay, I don't hear anything. All right. So get ready for the quiz. Get your cell phones out to take pictures. And so you know the way it works. As usual, once I give you the quiz, I'll put you in your breakout groups. You can stay as long or as short as you want until 6:55. If your breakout room gets too small, then be ready for me to move you to a different breakout room. And as usual, this is due Tuesday, just at the beginning of class, so you have until what, 5:40 Tuesday as usual. Okay. And so let me show it to you, and then I'll set you up for your breakout rooms, and that'll be it for today. Okay. So let me see if I can get this here. Okay, here we go. So take a picture of this. I'll read it also. A revenue function is given by R of X, revenue function is 450X minus X squared. Find the value of X which maximizes the revenue, and then give the maximum revenue. Okay, so 450X minus X squared. Find the value of X which maximizes the revenue. So your solution should have the X and also the revenue there. Okay, I'll just blab a little longer. So you want to take the first derivative and take the second derivative. Okay, first derivative, second derivative. Set the first derivative equal to 0. The second derivative will determine whether you have a maximum or a minimum. Okay. All right, so that's it. Let me stop the share, set you up with your breakout rooms. You can go ahead and get started. And I will pause the recording.